transformation formula. In this, these are the 4 transformation formulas which we're going to derive using the conversion of product to some other difference formulas. Okay, so let's derive one by one and take few examples to better understand. So let's derive one by one and take few examples for better understanding. Just now we have proved in the previous lecture videos, we have seen how to prove the convert conversion of product to some odd differences, right? So using the same thing, we are gonna do this. So if you carefully observe, now this can be written as sine of a plus b plus sine of a minus b, right? So here we need to assume that a plus b is nothing but c and a minus b is nothing but d. So for all these 4 cases, so for all these 4 formulas, we need to assume the same thing. A plus b is c over here and a minus b is d over here. So if we assume in such a way, so a plus b becomes c and a minus b is d. So we are assuming this. So let these are equal. So from here we can write it as 2a is c plus d. So a is nothing but c plus d by 2. If you substitute this a in any of this equation, you will get b as c minus d by 2. You need to remember this, that is a is c plus d by 2 and b is c minus d by 2. So using these two, we're gonna derive all these 4 formulas. The first formula is sin c plus sin d is nothing but 2 sin c plus d by 2 into cos c minus d by 2. So just now we have written a and b in terms of c and d. That is nothing but a is equal to c plus d by 2 and b is nothing but c minus d by 2. And we also know the formula of sin a plus b plus sin of a minus b is nothing but 2 sin a cos b. So in this LHS part, just substitute this a and b values. You will get it as sin a is nothing but c plus d by 2 plus b is c minus d by 2 plus sin c plus d by 2 minus c minus d by 2. Again here also substitute the values, that is 2 sin c plus d by 2 into cos c minus d by 2. So when you simplify here, you will get it as 2c by 2, which is nothing but just c. So sin c plus sin. Here also 2d by 2, it becomes sin d. And it becomes 2 sin c plus d by 2 cos c minus d by 2. So from this formula, you can prove this formula. Okay, so let's see an example so that you'll get a clear idea where to use these kind of formulas. In this question, we need to prove sine 2x plus 2 sine 4x plus sine 6x is nothing but 4 cos square x into sine 4x. So here, the basic approach on LHS side will be, we need to first sum up the two values and next again sum up with the third value. So the basic confusion starts here. Which two values we need to sum up first? Either these two or these two or these two. So here you need to sum up the first and third value, that is these both. Why? Because when you do this, you will get something related to sine 4x. So that afterwards you can take sine 4x as common and do the remaining solution, which will be easier. So how to get this strike, like how to get this logic or how to strike these kind of things to the mind is, it will strike when you do lots and lots of practice. So here, first let's sum up these two values. So here, let C will be 2x and D will be 6x. So we can write it as 2 sine, use this formula, 2 sine C plus D by 2. So 2x plus 6x is 8x by 2 into cos C minus D, which is minus 4x by 2. Write this term as it is. So plus 2 sine 4x. So it becomes 2 sine 8 by 2 is 4x. Cos of minus theta, which is nothing but cos theta. Cos 2x plus 2 sine 4x. I already told you, right? So from these two, you can take 2 sine 4x common. So it becomes 2 sine 4x and the leftover part is cos 2x plus 1. So here, if you remember, the basic formula for cos 2x is 2 cos square x minus 1. So substitute this formula over here. We'll get it as 2 sine 4x, 2 cos square x minus 1 plus 1. So these two values cancel and the final part is 4 cos square x into sine 4x. So this is the required RHS. The second formula is sin C minus sin D is nothing but 2 cos C plus D by 2 into sin C minus D by 2. So just now we have seen how to write the value of A and B in terms of C and D, which is nothing but A will be C plus D by 2 and B is C minus D by 2. So according to the formula of sin A plus B minus sin A minus B, which is nothing but 2 cos A sin B. So in this whole formula, use the value of A and B. So it becomes sin A is C plus D by 2 plus C minus D by 2 minus sin C plus D by 2 minus C minus D by 2. 2 cos A. A is C plus D by 2 and sin C minus D by 2. This we can write it as 2C by 2, which is nothing but C. Sin C minus sin 2D by 2, which is D. 2 cos C plus D by 2 and sin C minus D by 2. So from this formula, we have derived this one. So let's see an example, like where to use these formulas in questions. So in this question, we need to prove LHS is equal to RHS. So here, this is in the form of sin C minus sin D. So here C is nothing but x, D is nothing but 3x. And if you observe the denominator, it's like sine square theta minus cos square theta, which is nothing but formula of cos 2 theta, right? So just substitute the values in this formula. It becomes sine c minus sine d is nothing but 2 cos c plus d by 2, which is nothing but x plus 3x is 4x by 2 sine x minus 3x is minus 2x by 2 upon this is nothing but cos theta, cos 2 theta. So cos 2x. So this we can write it as 2 cos 2x. Sine of minus theta is nothing but minus sine theta. So minus sine 2 gets cancelled, it is x upon cos 2x. This one this gets cancelled. Here it's actually minus cos 2 theta. So here also in the denominator you'll get minus sine and this minus minus also get cancelled, which is nothing but 2 sine x. So this is the required RHS to this question. Third formula is cos c plus cos d is nothing but 2 cos c plus d by 2 into cos c minus d by 2. So to prove this formula, we need to have the values of a and b in terms of c and d, which we have already done. So a becomes c plus d by 2 and b is nothing but c minus d by 2. So we know the formula of cos a plus b plus cos of a minus b, which is nothing but 2 cos a cos b. So just substitute this a and b values in this whole formula. So substitute here, which is nothing but cos c plus d by 2 plus c minus d by 2 plus cos c plus d by 2 minus c minus d by 2. And here also substitute cos c plus d by 2 and cos c minus d by 2. So when we sum it up, you will get it as cos c plus cos d is nothing but 2 cos c plus d by 2 into cos c minus d by 2. So we can prove this from using this formula and we'll get it as this formula. So let's see a few examples where to use these kind of formulas. Here we need to prove LHS is equal to RHS. So here in the numerator, if you see, you can observe that sine C. So here this can be written as C plus sine D. Similarly, in the denominator it is cos C plus cos D. So first assumption is let C is 5x and D is 3x. And here in the numerator, we need to use the formula of sin C plus sin D. So what's the formula? Sin C plus sin D is nothing but 2 sine of C plus D by 2 into cos C minus D by 2. Whereas in the denominator, we need to use this formula. So let's solve this question. So from the LHS, substitute this values here, which becomes 2 sine C plus D, which is 8x by 2 into cos 5 minus 3, which is 2x by 2 upon use this formula now. So it becomes 2 cos 8x by 2 and cos 2x by 2. So here we can cancel these two values. So the leftover is sine 4x by cos 4x. Sin theta by cos theta is nothing but tan theta. Theta is nothing but 4x. So finally, we got the required RHS to this question. So here we need to prove LHS is equal to RHS. So if you observe sine C, so here x will be C, sine D, y will be D. Similarly, in the denominator it is cos C plus cos D. So first assumption is let C is nothing but x and D is nothing but y. And in the numerator we need to use the formula of sine C minus sine D, which is nothing but 2 cos C plus D by 2 into sine C minus D by 2. And in the denominator, you need to use this formula. So just substitute all the values. So from LHS, we can write it as, in the numerator, use this formula. So 2 cos C is nothing but x and D is nothing but y. And sine x minus y by 2 upon, by using this formula, we'll get as 2 cos x plus y by 2 and cos x minus y by 2. So these two values get cancelled. Remaining is sine theta by cos theta is nothing but tan theta. Theta is nothing but x minus y by 2. So from here, we'll get the required RHS. The last formula, that is cos C minus cos D, which is nothing but minus 2 times sine C plus D by 2 into sine C minus D by 2. So to prove this formula, we need to have the values of A and B in terms of C and D. So we have already proved that, that is A is nothing but C plus D by 2 and B is C minus D by 2. And we also know the formula, that is cos A plus B minus cos A minus B, which is nothing but minus 2 sine A into sine B. So just simply use this A and B values over here, whole formula, both this LHS and RHS. So substitute it, that is cos C plus D by 2 plus C minus D by 2 minus cos C plus D by 2 minus C minus D by 2 into minus 2 times sine C plus D by 2 sine C minus D by 2. So here we'll get it as cos 2C by 2, which is C minus cos D, is equal to minus 2 sine C plus D by 2 into sine C minus D by 2. So hence we can prove this formula using this formula. So let's see a few questions. In this question, we need to prove LHS is equal to RHS. So if you observe, we can use the formula cos C minus cos D in the numerator, and we can use formula sin C minus sin D in the denominator. But here both C and D are separate. Here both C and D are different for both numerator and denominator. The main thing is to use the formulas correctly. So numerator we can use this formula, and denominator we need to use sin C minus sin D, which is nothing but 2 cos C plus D by 2 into sin C minus D by 2. So just use these two formulas. So from LHS, in the numerator use this formula, that is minus 2 sin C plus D. 9 plus 5 is 14x by 2 into sin 9x minus 5x is 4x by 2. And in the denominator it is 2 times of cos C plus D. So 20x by 2 into sine 17 minus 3 is 14. 14x by 2. So 2 gets cancelled. And if you observe, here sine 14x by 2 and sine 14x by 2 also get cancelled. So the remaining is minus 4x by 2 is nothing but sine 2x by cos 10x. So this is the required RHS to this question. In this question, it is given as we need to prove that LHS is equal to RHS. So if you observe here, the first thing is this is in the form of sine C plus sine D, and here it is sine C minus sine D. So first assumption is C is nothing but 5x and D is nothing but 3x. So sine C plus sine D is nothing but 2 times of sine C plus D by 2 into cos C minus D by 2. And similarly, sine C minus sine D is nothing but 2 cos C plus D by 2 and sine C minus D by 2. So just use these two formulas over here. And one more conversion, that is cot. Cot theta is nothing but cos theta by sine theta. So use all this and you can easily prove that LHS is equal to RHS. But there is no need to use this formula because we need this is in the RHS side. So from LHS we need to derive RHS. So just take the LHS part. Cot 4x can be written as cos 4x upon sin 4x into sin C plus sin D, which is 2 sin 5 plus 3 is 8x by 2 into cos 2x by 2. So we will get it as cos 4x by sin 4x into 2 sin 4x cos x. So this sin 4x and sin 4x gets cancelled. So 2 cos 4x into cos x. So this is the LHS. So let's take RHS also and see whether they are equal or not. So now we need to use this formula. So now we need to use this formula. It becomes cos x upon sin x into sin c minus sin d. So 2 cos 5 plus 3, 8x by 2 sin 2x by 2. So it becomes cos x upon sin x 2 cos 4x into sin x. Again sin x and sin x gets cancelled. From here we'll get it as 2 cos 4x into cos x, which is RHS, which is RHS. So if you observe clearly over here, LHS is equal to RHS. So hence proved.